I'm going to walk through how to both write and balance chemical equations. So we're going to break this up into two parts. Initially, we're going to go through and take a written description of the chemical reaction, write it out as an equation. And then once we've done that, then we'll go into how we take that written equation and actually balance it. So we're going to go through three equations today. The first two are shown here on the first screen. As we read through that first reaction, I want you to think about what substances we come across. So I'm actually going to highlight them as I read through that statement. So we have solid calcium reacts with chlorine gas to produce solid calcium chloride. So I've highlighted three different substances. Those are the three substances that are involved in this particular reaction. So those three substances should all show up in the written equation that we're going to write. We want to take each of these substances and convert it into the symbols for our equation. So we'll start with the calcium. Each substance we want to say, is this an element or is it a compound? So that'll help us figure out how we need to express it in the equation. So calcium's on the periodic table, so it is an element. When we come across elements, we also want to do a second question. We want to say, is this one of our diatomic elements? So if you remember from chapter 4, there are 7 elements that are naturally occurring as diatomic molecules, which means each particle or each molecule of that particular element has 2 atoms. There are 7 elements that are diatomic. Hydrogen, we have nitrogen, oxygen, and then all of our halogens, fluorine, chlorine, bromine, and iodine. Calcium is an element. It is not a diatomic element, so because it's not diatomic, we're just going to write it out as its symbol Ca. The S in parentheses here just tells us that that calcium is in the solid state, so it's just an indication of the state or the phase. Our second substance that we identified was chlorine. Chlorine is an element, and then we ask, is it diatomic? And it is one of our diatomic elements. So when we write chlorine, we're going to put that symbol, but we want to make sure and highlight that it's diatomic by writing this little subscript 2. That's my indication that it's one of our diatomic elements. Our third substance is the calcium chloride. So calcium chloride is a compound. We know it's a compound because it has 2 elements in its name. So once we recognize we have a compound, we want to go back to what we learned at the end of chapter 4 and chapter 5 to determine how we come up with the formula. Calcium is a metal, so we know that this is going to be an ionic compound, and we want to remember that for ionic compounds we need to balance out the charges of each of the ions. So calcium is in column 2, which means it's going to have a 2 positive charge as an ion. Chlorine is in column 7, so that means it's going to have a 1 negative charge as an ion. We remember what those charges mean, so the 2 positive means calcium atoms want to give away 2 electrons. The 1 negative means each chlorine atom wants to take an electron or gain an electron. So if calcium wants to give away 2, each chlorine wants to take 1, then I need to have 2 chlorine atoms to balance out that calcium atom in my ionic compound. So we're going to write calcium chloride as CaCl2. Again, the S just stands for, or just indicates that it's going to be a solid. So I want to just make a quick note here. So the CaCl2, that chlorine has the 2 after it because it's how we write that formula for the ionic compound. The 2 here after the chlorine is not because chlorine's diatomic. We only worry about whether or not an element is diatomic if it's all by itself in an equation. So we have our 3 different pieces of the equation. We've got our calcium, we've got our chlorine, and we've got our calcium chloride. So this completes that first part of the process for writing a balancing equation. So this is our written equation for the reaction that was described above. So let's look at number 2. We're going to do the same thing. We'll go a little bit quicker this time, but go through the same process. So I have solid rubidium reacts with gaseous iodine to produce solid rubidium iodide. So again, I have 3 substances, which means I need to have 3 pieces in my chemical equation. First one, rubidium, is an element. It's not a diatomic element, so we're just going to write it as Rb. Second one is iodine. Iodine is a diatomic element, so we need to write this as I2. And then rubidium iodide, this is a compound. Rubidium is a metal, so it's an ionic compound. We need to worry about charges. Rubidium is 1 positive. Iodide is at column 7, so it's 1 negative. So rubidium wants to give away an electron, iodine wants to gain an electron. So I just need one of each of these atoms to write out my formula and to have a balanced compound. So for the second reaction, we again have our 3 pieces. So we've got rubidium, we've got our iodine, and we've got our compound in rubidium iodide. So this is the first step in writing out each of the pieces. I do want to highlight here a common mistake. So one thing I see a lot is that students may want to write this rubidium iodide as RbI2. And I think this comes from the fact that over here we have rubidium, here we have iodine as a diatomic, and so it may seem kind of natural just to put those two things together on the product side. So I want to caution against this. Every time we do an equation from a written description of the reaction, we want to look at each piece independently. So to figure out what to write for rubidium, I want to just look at rubidium. Iodine, I just think about iodine. When I get to the compound, I want to think about just what is the formula for that compound. We don't want to think about anything else that comes before it. We want to do each piece independently. This here is not correct because this is not rubidium iodide. This is some other compound. It actually is not a stable compound because, as we showed up here with the charges, I don't want to have 2 iodines with 1 rubidium because it's not going to balance out and be neutral. So just try to avoid doing this. If you go through and just pick each substance and then independently write out each substance below, then you won't run into the problem doing this, getting those mixed up that way. Let's look at this reaction that we're going to do. So again, we'll go through this one kind of quickly. So we've got hydrogen, oxygen, and water. Those are our 3 substances. Hydrogen and oxygen are both diatomic, so we're going to indicate that here in the equation. And then our water is just H2O. So we've got each of these pieces indicated in our chemical equation. So now let's think about the next piece of this, which is the balancing piece. So to do, we're going to take a visual look at what this chemical equation is actually telling me. So we're going to start with this last one we did. So we've got the hydrogen, oxygen to produce water vapor. So if I have something that says H2, H2 is a diatomic element. So my H2 tells me that each molecule or each piece of H2 has 2 hydrogen atoms. So this is one H2 molecule, 2 hydrogen atoms. This is one O2 molecule, has 2 oxygen atoms. This is one H2O molecule, it has 1 oxygen atom and 2 hydrogen atoms. So let's think a little bit about what this is actually showing us. So I've got 2 hydrogen atoms. I'm going to add to it my 2 oxygen atoms, and we're going to produce, according to what I have here, 1 oxygen atom and 2 hydrogen atoms. Now we have something called the law of conservation of mass, and the law of conservation of mass says that we can't create or destroy matter. So if I look at this scenario here, it looks like I've got 2 hydrogen, I end up with 2 hydrogen. I've got 2 oxygen, but I only end up with 1 oxygen here at the end. So that extra oxygen atom had to have gone somewhere. So law of conservation of mass says it just can't just disappear. So what can we do with that extra oxygen atom? So you may think, well, maybe we can just put it over here to the side, and now we have the 2 oxygen atoms on the product side. However, the reaction that we wrote said that we have H2O on the product side. It does not say we have H2O plus just an extra oxygen over there. That would be a different reaction, again, not the one that we actually wrote here. So that's not an option. We can't just kind of tack it on to the end here. What we're going to have to do is have that extra oxygen over on this side, but the only way we can add something extra to the side is to add another entire piece of H2O. So that I'll look at here. So again, in this case, I've got that original water molecule, And the only way I can end up with that second oxygen molecule over here is to add an entire new water molecule itself. So now I have one water molecule and I have two water molecules. So this fixed our problem. We have two oxygens. We have two oxygens on this side. But now we're stuck with a problem with our hydrogens. So if we look at our hydrogens, I've got 1, 2, 3, 4 on the product side, and now I only have 2 on the reactant side. So again, law of conservation of mass says I can't start with 2 hydrogen atoms and end up with 4 on the product side, because that means I would have been creating hydrogen atoms. So we need to fix this by adding additional hydrogen on the reactant side. So now we've got here on this slide, I've got a total of 4 hydrogen atoms on the reactant side. I've got a total of 2 oxygen atoms on the reactant side. And then on the product side, I again have 4 hydrogen, and now I have 2 oxygen. So we're in good shape. The law of conservation is now valid because I have the same total number of atoms of each element on both sides of the equation. And now we want to just represent this balancing or accounting of all of those atoms back in our original equation up here. So on this side over here, we've got 4 hydrogen atoms, but we only have 2 H2 molecules. Okay, then over here, we're showing 2 oxygen atoms, but we only have 1 O2 molecule. And on this side, we've got our 2 H2O molecules, but we actually have 2 oxygen atoms. We have 4 hydrogen atoms, and we have 2 H2O molecules. Okay, so the basis of balancing equations is that we have this right. So we have the same number of atoms on each side. So 4 hydrogen, 4 hydrogen, 2 oxygen, 2 oxygen. But the way we communicate that in our equation up here is through those pieces or the molecules. So I'm going to take this down here, that I have 2 H2 molecules, 1 O2 molecule, and 2 H2O molecules. And these I'm going to write up in front of our balanced equation. So I'm going to put a 2 up here. That 2 is going to represent that I have 2 pieces or 2 molecules of H2. In front of the O2, I'm going to write a 1. We don't generally write the 1, but I'm going to put the 1 here just sort of for emphasis on what we're looking at. So that means I have 1 piece of O2. And then in front of the H2O, in front of the water down here, I'm going to put another 2. These big numbers here up front, we call these coefficients. These coefficients are how we indicate that a reaction is going to be balanced. This slide is just a summary of what we did on the previous one, just to kind of clean it up a little bit and show that we have our equation that we wrote first, right? We just wrote out each of the pieces based on the written description. And now we need to balance it, and that balancing is just really an accounting of the atoms on each side. So to fully complete this writing and balancing of this reaction, we would have each of the pieces, and then we would have our coefficients out front that result in us having the appropriate number of atoms of each element on each side of that reaction. And again, the reason we have to do this is because of that law of conservation of mass, right? That says that we have to have the same number of atoms of each element on each side. Right, I want to highlight here again one of those things not to do. So when we wrote out these pieces, we wrote H2, O2, and H2O. And we talked about earlier on how we had that 1 extra oxygen atom. So what you don't want to do is to try to balance this equation by using a subscript, right? So we don't want to say this is now H2O2 to get that to work. So if we did that, yes, we would have 2 oxygen atoms here, 2 here, and then 2 hydrogen, and it might look nice. But we never, ever, ever, ever balance equations using these subscripts. You can only balance an equation using coefficients. And again, the reason for that is that if I do this H2O2, now my molecule looks like this. And it's no longer water, it's actually hydrogen peroxide. But the reaction that we were given says that we're producing water. So this is not something that we want to do. You never ever balance with subscripts, only with those big coefficients out front. Let's go back to those first two equations that we had written out, but we hadn't gone back and balanced. And I'm going to show you here one method that some people like to use when balancing equations. Some people can kind of just go back and forth from side to side and get it to work out, but some people like more of a process. And so I'm going to show you how to use a little table. So we're going to just make something that looks like this. We're going to do reactants on one side, products on the other side, and then we're just going to write down in the middle each of the elements that are in our reaction. So here I just have calcium and I have chlorine. Then we're just going to tally them up on each side. So on the reactant side, I have 1 calcium and I have 2 chlorine atoms. So we just look at what's indicated in the reaction as we've first written it. On the product side, this tells me 1 calcium and again 2 chlorine. So I've got 1 calcium and 2 chlorine. So remember, our goal is to have this equal numbers of atoms of each element on each side. So looking at our table, I've got 1 calcium on each side, 2 chlorine on each side, so we're good to go. For this particular case, when we wrote that equation out, it was already balanced, so we didn't have to do anything else to it. The last one we're going to do was that second reaction that we looked at. So again, I'm going to use the table here. So we've got reactants, we've got products. In this case, I just have rubidium and I have iodine. So we'll check the reactant side first. I've got 1 rubidium, I've got 2 iodine here. So I've got 1 and 2. On the product side, I've got 1 rubidium and I've got 1 iodine. So when we do the check this time, we notice that our rubidium is good, but our iodine is not balanced. So I need to make an adjustment. And remember, we're going to only make those adjustments using the coefficients out front. So I can tell from here I need more rubidium on the product side, and I actually need 2. So we're going to take our coefficient and put it out front here. So remember, when I put this coefficient out front, it's going to apply to everything that comes after it. So I now have 2 pieces of this rubidium iodide. So that means I have 2 rubidium ions and I have 2 iodine ions as well. So when we go back to our table, we need to make sure and change everything that's been affected by what we just did. So I did fix my iodine. I now have 2 of those. But I also adjusted that rubidium, so I need to change that one as well. So you'll notice when we did that, now my iodine are good, but now my rubidium are off. So I need to come back again. I need to fix this side of the reactant. So I need to do that. We need to put a 2 out here in front of the rubidium. When I do that, now I have 2 rubidium in my table. Now when I go, I've got 2 rubidium on each side, and I've got 2 iodine on each side. So we're in good shape. And now we know that we've balanced that equation. Sometimes it takes kind of several steps of going back and forth to actually get your equation to be balanced. This is a fairly simple one where we just had to make 2 changes, but sometimes you need to kind of go back and forth a couple times to get it to work. Some people don't like to use that table method, so if that's the case and you are more comfortable maybe drawing pictures, then again, you can do this at any point, just drawing pictures. So if I take that starting reaction, and this first row would be the pictures that you could draw, right? So this is a rubidium. I've got 1 rubidium atom. This is my iodine. It's diatomic, so I've got 2 atoms. This is my rubidium iodide. I've got 1 of each. So if we look at that first set there, I've got 1 rubidium, it's good. I've got 2 iodine, I've only got 1 iodine, so that's what I need to fix. I need to add a second rubidium iodide molecule or piece there. If I do that, now I've got 2 iodines. I need to add a second one here. Then once you have that drawn out, then you're just going to go and you're just going to count each piece. So I've got 2 pieces here. I've got 1 piece here, so I don't need to put anything in there. And then over here I've got, again, 2 pieces. So I would put a 2 here. So we end up with the same thing, it's just a different method for getting there.